What's a coefficient?
Today's 1024. If you missed class, we're covering section 5.1. 25x cubed is a monomial. A monomial can be a single number, a single letter, or the product of numbers and letters, but there is no adding or subtracting taking place. In this term, we have three parts. We have the coefficient, which is the number in front of the variable. If there is no number in front of the variable, it is understood to be 1. So it still has a coefficient. The variable is x, and the exponent or power is 3. Now, knowing these terms is extremely important because we're going to be discussing rules today. And in the rules, we're going to say stuff like add the exponents, multiply the coefficients. So if you don't know what a coefficient is, you don't know what to multiply. Correct? Okay. First thing we're going to touch on is negative exponents. What do we mean when we raise something to a negative power? Well, the first thing you need to know is that this negative symbol in front of this exponent is not the same thing as the negatives that we've been working with, where you have a number line, and the negative numbers are everything to the left of 0. And when you're adding negatives or multiplying negatives, you have specific rules. This negative, Tyler, get in the zone. This negative is a set of instructions which says take the inverse of the base of this exponent. Now the base of the exponent is whatever is being raised to that power. So x is the base. So let me ask you this. What is the inverse, if it's saying take the inverse of x? What is the inverse of x?
1 over x.
1 over x. Negative x is the opposite of x. Okay? The inverse refers to the multiplicative inverse when you flip it. So, x to the negative 1 power is actually 1 over x to the positive 1. Now this is very important too. Notice the negative is not there anymore. If I still had the negative with the exponent, it would mean flip it again, right? So I'd flip it again, I'd be right back where I started. And if I still had the negative, I'd flip it again. And I'd keep flipping until the day I died, and I'd never get an answer. Okay? When you buy something new that needs to be put together, have any of you ever assembled something where they had instructions? And guys, I'm sure you just didn't even look at the instructions because, you know, you're men and you can just do things on your own, right?
Mm-hmm.
And us girls, we follow all the instructions to a T. And it's all nice and pretty and it looks right when we're finished. No, it doesn't. Not my stuff. Anyway, okay. See, my husband puts stuff together and he doesn't read the instructions, and then he's putting pieces in the wrong part and he's trying to make them fit, and then he breaks it, and then so we're one part short, and anyway. When I'm through with the instructions, I throw them away because I've put this thing together, it's done, I don't need the instructions anymore. If the negative exponent is a set of instructions saying to invert the base, once you have inverted the base, throw your instructions away. You don't need the negative anymore. You've done it. Okay? Now let's look at some more examples of negative exponents. If I asked you to take this expression, which is a monomial, because there's no addition or subtraction occurring, and to rewrite it containing only positive exponents, we need to identify which one of these variables contains the instructions to take the inverse. X or Y?
X.
Only the X. Okay? So if I invert X, it becomes 1 over X, correct? It's 1 over X to the 4th. And that is still being multiplied by Y, which was in the numerator. And how do we multiply fractions? Straight across. 1 times Y is Y. X to the 4th times 1 is X to the 4th. I gave you this expression, 1 over x to the negative 2y cubed, the doodles that I have on my page are the same things that you should do in order to fix your problems. Identify which variable contains the instructions. Circle it. And then show where it goes. If it's now in the denominator, I need to move it to the numerator. But y did not contain the instructions to invert it, so y stays where it started. Annalise, you have a question?
Why would you put y over 1 if y wasn't negative?
It's no. Y is a whole number. Okay? And so since I'm multiplying it times a fraction, just to make it more clear exactly what y is supposed to be multiplied with. See what I'm saying? I'm writing it as a fraction. I haven't inverted it. Here, y was a whole number. Here, y is still a whole number. It's y over 1. Okay? Every whole number is understood to be over 1. But the only reason I put it that way is to show that when we multiply straight across, that's what we get. Now, you don't have to go through this entire process. You can simply do this. But I wanted to break it down, break it apart, and show you exactly how we get there. All right? But all you need to do is this. Identify which one needs to be moved, and move it. Does everybody have these examples on your paper? Everything that's up here, you should be putting on your paper. Remember, we are turning notes in at the end of the quarter for a grade. Take this expression, and before I reveal to you the answer, I want you to see if you can come up with the correct or the fixed fraction. Do you have a question or an answer?
Question. Is that x to the negative 2?
Yes, it's x to the negative 2y cubed divided by z to the negative 4. Okay, now this shouldn't take long. What do we need to do? Identify which ones are negative and invert them. If they're in the numerator, move them to the denominator. If they're in the denominator, move them to the numerator. Which ones need to move? X and Z need to move. Y doesn't go anywhere. All right, so the first thing we do is we identify which ones need moving, and then we move them.
Doesn't matter which order y and z is
No, it doesn't matter. Try to put them in alphabetical order, but it really doesn't matter. That just makes grading for me easier. If I can just, but no, it really doesn't matter. So y cubed z to the 4th divided by x squared would be the final answer. Okay? That's working with negative exponents. Multiplying monomials. What you're going to see as we start working with variables, radicals, all kinds of different things in algebra, is that all the rules basically are the same. The rules that we started with for the 4 operations for fractions are the same for basically everything. So let's review real quick. If you're adding or subtracting fractions, Clint, what must you have? You have to have a common denominator, okay? Now let's use the word same. You have to have the same denominator. You cannot add them until they have the same denominator. When you're adding or subtracting variables, what do you have to have? Same variables, right?